Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss the topic DRAM, memory cell by using MOS transistors. Right, let us see this one. Okay, so what is a memory? Memory is a storage device. So memory is a storage device. It will be classified memory. So memory is a storage device, right? Storage device which we can use it in storage device which we can use it in which we can use it in which we can use it in personal systems, laptop and mobiles. Use it in personal system, desktop systems, laptop, mobiles, etc. So this is the definition of memory, right? Memory is a storage device. So DRAM is a memory device. It is a memory device, right? Memory is a storage device, so which we can use it in personal computers, laptop, mobiles, any communication device. Like we can say it is in any communication device, any communication storage device, any communication storage device. There you can use memory. Okay, right. Memory classified into, let us see the memory classifications. Memory classification into SRAM, DRAM. It is comes under ROM, RAM, PROM and EEPROM. Basically, it is RAM, random access memory, and we have read-only memory, right? RAM, random access memory. This is a random access memory. You already know about the what is a memory, which you can use mobile, personal systems, computers and laptops also. Memory. ROM is random access memory, right? Random access memory. You know all the differences. ROM is a permanent storage. RAM is a temporary storage. It is a volatile and non-volatile. You already studied everything. But how it will be designed, you can see, right? Again, RAM is classified into SRAM and DRAM. You can see this one, SRAM and DRAM. SRAM and DRAM. So this is what we are going to study about this DRAM memory cell designed by MOS transistor, right? It is a PROM, programmable read-only memory, and EEPROM, right? This is EEPROM. Okay, so let us see this one. In the classification, we'll study about what is SRAM, what is DRAM, and what is ROM and what is a PROM and EEPROM. So today we will discuss what is a DRAM, dynamic random access memory, right? How it will be designed by using MOS transistor, right? DRAM memory cell, okay? DRAM. DRAM is a dynamic random access memory. So it is defined by dynamic random access memory. Dynamic random access memory. So dynamically the memory access. Dynamically memory access. So dynamic random access memory. Okay. So dynamically random access memory. So it is a one of the memory location in RAM, right? Dynamically the data storage. So we have static RAM and dynamic RAM. Now this RAM, dynamic RAM, today we can see the DRAM designed by 3 transistor memory cell. 3 transistor DRAM. 3 transistor DRAM, and another one is 1 transistor DRAM. 1 transistor DRAM. How it will be designed? Okay, how it will be designed? So DRAM is a dynamically data storage. So DRAM is dynamically storage, like examples, applications. Let us see this one. DRAM. Then we see the types of this 3 transistor. DRAM, data storage dynamically. Okay, it is dynamic. Okay, it is dynamic. More store data than SRAM. More storage data than SRAM, right? SRAM, more storage data than SRAM. It is used capacitor. So every time refresh the capacitor, every time refresh to store the data, every time, right? Every time refresh the data for storage. For storage, every time we can refresh the data, right? So more stored data than SRAM. So every time refresh the data for data storage, and also, so which we can say it is the low cost effective device. Than the SRAM, cost effective design. It is one part of the memory, SRAM and DRAM. Example, we can say live, when we are watching live update, the data stored in dynamical DRAM. So live update, okay, live game, live games, okay, live games, or the applications of DRAM. So other than this, remaining data stored in SRAM. SRAM and DRAM, two are the memory, separate memory locations, memory. So DRAM is, we can use more data storage required. It is live update. Every time it will be dynamically update live games. When you are playing a live games in system or mobile or in a laptop. So live update, when you are watching, like if you say example, cricket we are watching. So every time the data will be updated. The data will be stored in DRAM. The data will be stored in DRAM. So remaining applications are stored in SRAM. So dynamically data storage, more data storage, live update or live games. So are the example data stored in DRAM, right? Now let us see the one application, one type of DRAM. One is 3 transistor memory cell. 3 transistor memory cell. 3 transistor DRAM. Yeah, this one we are going to discuss. 3 transistor and 1 transistor is there. 3 transistor DRAM, right? 3 transistor DRAM. Okay, let us see the design part. How it will be data stored in this. How it will be data stored in this. Right, let us see the design structure by using a MOS transistors. Right, this may be asked in examinations. Explain about DRAM. You can write the DRAM and 3 transistor memory cell. Right, let us see this one. So which transistor it is? You see, it is a depletion mode transistor, right? It is a depletion mode transistor, right? So it is connected to, it is a pull-up transistor. Now the pull-down transistors are, so you can see this one. Again, this is enhancement mode transistor. Enhancement mode transistor. Right. Here one transistor. And here one more transistor, which is connected over here. Okay. Okay. Right. And here we apply gate read write operation. So let us see. Here also we can use, instead of this depletion mode transistor, we can also use PMOS transistor. We can also use PMOS transistor. Right, a PMOS transistor is a bubble across this. So this is VDD. Right, VDD. Depletion mode, it is a pull-up transistor. Pull-up transistor. Right, these are pull-down transistors. And here is a bus, data storage bus. So temporary data storage bus register. Right. So here we are applying the gate voltage, write operation and read operation. So transistor T1, transistor T2, transistor T3. So 3 transistors are here, T1, T2, T3. So T3 transistor we are applying read operation, write operation. In any memory location, in any memory, we can write into memory, we can read out from the memory. So WR is a, so 3 transistor DRAM, 2 operations can be performed. 2 operations performed. What are the 2 operations in a memory? In a memory location, mobile or laptop or a personal system, we can store the data. There we can do the 2 operations. So 2 operations. One is WR. WR means write operation. Okay, write operation. Okay, write into the memory cell. Okay, another is, or second one is read operation, RD. So it is called a read operation, right? Read operation, right? Read write operation. 2 operations perform in a memory. Okay, in any memory we can write operation, read operation. Whereas in ROM only read operation. We cannot write it. So it is a permanently storage device. Okay, random access memory means when the power will be off, data will be erased. So that is a random access memory. It will be classified into 2 types, SRAM and DRAM. So DRAM is more data storage For example, if you use live data, right, live updates, so it will be dynamically changing. That's why the data stored in dynamic RAM. So other applications are stored in SRAM. More data stored in DRAM. So it is two operations can be performed: write into the memory cell, read from the memory cell. So it is a memory which is stored in the transistors, right? The data bus is here: pull up transistor, T1 transistor, T2 transistor, and T3 transistor. The read write operation is applied. So first let us see this one. So whenever the first one, when WR is equal to 1, write operation is equal to 1, read operation is equal to 0. Now what happens here? Write operation is equal to 1. Now write operation is equal to 1 here. Write operation is equal to 1. Read operation is equal to 0. So write operation is equal to 1. Already that VDD passing through pull up is always on. It is pull up on transistor. Okay, it is on transistor. The VDD passing through this one. Okay, it is already connected, supply, and bus is a data stored. So this bus is a, so 1 bit data stored, 1 bit data store, 1 bit data store, right? 1 bit data store ma. So this is 1 bit data stored, 1 bit data stored. So whenever write operation is equal to 1, the data on this bus is connected to this one, and which will be passed through this. This is a gate terminal, this is a source terminal, and drain terminal. So T1 is on, then it will be connected to the capacitance of the T2 gate capacitance of the T2 transistor, right? Gate capacitance of the T2 transistor. This is a CG, gate capacitance of the T2 transistor, right? Let us see. So when WR is equal to 1, read operation is equal to 0. So T1 is on, data stored, data 1 bit data. You can say it is 1 bit data, stored, 1 bit data stored, 1 bit data stored at T2 transistor, T2 gate capacitance, T2 also stored at T2. So T2 is on, stored at CG, gate capacitance of T2, we call it is CG is nothing but gate capacitance, right? Gate capacitance, okay, gate capacitance. So T3 is off, T3 off, because RD is equal to 0, this read operation is equal to 0. You see this one now, read operation is equal to 0 means gate voltage is 0. Gate voltage 0 means this will be off transistor. Now T3 will be off transistor. Write operation is equal to 1. Data on the bus passing through T1 and connected to the T2 transistor, right? So this will be happen. Data on the 1 bit data, 1 bit data on the 1 bit, we can write this 1 bit data on the bus passing through T1, and then it is connected to, and then it is stored CG of T2, right? CG of T2. This is happened when write operation is equal to 1. So write operation right into the transistor cell, memory cell. So what is a here memory cell? Transistor is a memory cell. What is a memory cell here? Transistor is a memory cell. Right into the memory cell. WR is equal to 1, T1 is on, the gate voltage is on, channel established, then it is connected to the source, is connected to the data bus, the signal passing through this, which is connected to the transistor T2, T2 will be on, it is stored in the CG, gate to channel capacitance, right? The second condition, if you see the second condition, what is the second condition? Tell me, ma. Now RD is equal to 1. Now RD is equal to 1. WR is equal to 0. Write operation is equal to 0. So after write operation, if you want to read out the data, write operation is equal to 0, read operation is equal to 1. Then what happens? Then what happens? So transistor T1 is off. Right? T1 is off. T3 is on. So T2 is also on. T2 is already on. So T2 already on. It is stored 1 bit data. Stored 1 bit data, right? Stored 1 bit data. So both T3 and T2 is on. So both T3 pull down to ground. So it is both T3 and T2 on. So both transistors are on. So this is already on when write operation is equal to 0. Now this will be 0. Now read operation is equal to 1. T3 is on. T1 is off. Then data storage over here. T2. Now what happens? Then it will be pulled down. Then it is connected to the bus. Now the logic 1 is connected to the logic 1 which is stored in T2 is connected to the data bus. It is connected to ground potential, but it is stored again replaced onto the bus, and both our transistors are on. The logic 1 is connected to the bus. Right? So both are on. Logic 1, the stored data is connected to, you can say, stored data is connected to the bus. Right? Stored data connected to the bus. So this is a read write operation of the 3 transistor memory cell. Right? 3 transistor memory cell. So write operation is equal to 1. This will be on and it will be connected to the bus 1 bit data. Let us take it is a 1 bit data that will be passing through source and drain, which is connected to T2. T2 will be on, stored at the gate to channel capacitance. We call it is CG. Okay, so whenever this will be on, then it will be connected to the bus. Then RD is equal to 1. Read out and read on to the bus. So RD is equal to 1. What happens here? Read on to the bus, connected to the bus, means read onto the bus. Okay, read onto the bus. So this is a 1 bit storage data. It is a 1 bit storage data. So like this million number of transistors in the DRAM. So more storage data in digital, right? When it will be converting into analog to digital, the data stored in digital form in the memory location. In the memory location, it is stored in digital, right? It is stored in memory in digital form, right? In digital form means it is connected through the registers. It will be connected to the memory cells. What is the memory cell here? Transistor is a memory cell which we can hold the 1 bit data. So like this, millions of data is stored, millions, and depend on the data storage. So depend on the transistors are stored, right? This is a 3 transistor memory cell, like it is a 3 transistor memory cell, right? If you see this another one, the second one is 1 bit memory cell, 1 bit memory cell. DRAM, right? 1 bit memory cell DRAM, right? Let us see this one. 1 bit memory cell, we are using 1 transistor, right? Connected to over here. and from here we have capacitance, capacitor terminal. Here we are applying read write operation and read operation. Okay, it is a row select, right? It is a MOS transistor. Now we can say it is a load capacitance. Okay, so what happens in this? When write operation is equal to 1, write into the memory cell, read out from the memory cell, right? Let us see this one. First one, when write operation is equal to 1, WR is equal to 1, RD is equal to 0, RD is equal to 0, row select high, okay, row selection is high. So from row selection is high, then what happens? So transistor is on, transistor on, transistor on, okay, transistor on. Let us take it is T1 transistor. Let us take it is a T1 transistor. Let us transistor T1, right? Transistor T1 is on because row select is equal to high. Row select is equal to 1. Gate voltage is 1. For NMOS transistor, gate voltage 1, it will be on. So the channel established, then write operation is equal to 1. Then the data will be passing through these. For example, if you take here a memory location, if you take a memory location, right? If you select a one particular row, if you select a one particular row, right? If you select a one particular row, here it is stored by 1100 like. Okay, if it is a memory, it is a memory, right? A memory device, right? If you select a row, so taking the data, let us take the bus or whatever may be. Okay, so the data will be taken selection and it will be stored in the capacitor, means capacitor is charged, capacitor is charged. So row selection is high, transistor is on, so capacitor, load capacitor, load capacitor charged, load capacitor, load capacitor charged ma. Okay, load capacitor charged, load capacitance is charged. Now when read operation is equal to 1, read operation is equal to 1, WR is equal to 0. So through the same line, again row select is high, row select is high, again row select is high, again row select is high. Okay, row select is high, again transistor is on, the same path it will be discharged and read into the memory cell. Okay, memory to in the transistor, transistor to memory location. So transistor is on, transistor is on T1. Okay, again it will be replaced into the memory. So read out from the transistor, so read out from the transistor, read out from capacitance, read out from capacitance, right? Read out from capacitance. So this is what happened ma, this is what happened. So capacitor is charged and data stored, data stored, 1 bit data stored, 1 bit data, 1 bit data stored, 1 bit data stored. Again it will be replaced, again it will be replaced into the memory location. What happens? Capacitor is through the transistor, read operation is equal read out from the capacitance, replaced into the memory cell, right? This will be happen, right? If you see this one, when row selection is equal to 1, WR is equal to 1, WR is equal to 1, read operation is equal to 0. So row selection is high, the data will be passing through and capacitor will be high. Okay, capacitor is charged, capacitor is charged ma, capacitor is charged. Now whenever write operation is equal to 0 and read operation is equal to 1, then it will be read out again through the same line, again replace it into the location, replace it into the location according to the read write operation. So write into the transistor, that is a capacitor is charged, read from the transistor, read from the capacitance, discharged to the same path, again replace into the memory location. So here memory to this transistor, transistor to memory. Okay, write and read, write into this capacitance, read out the capacitance. So this may be happened in this DRAM, 1 bit and three transistor also 1 bit storage. Here 1 bit we can use the capacitor, right? So this is about DRAM, right? Next class we discuss SRAM. So please share and like, subscribe the channel. Thank you.